Today we are going to have a lecture on optics. Optics means the light, with the help of that we can see objects, that means it is called visible light. But one thing you must remember, visible light means as if you can see the light, the electromagnetic wave of which there is a portion which is called visible light, actually that light cannot be seen. Let us consider a Gedanken experiment. Say we have a room, and in this room there is a mirror in one wall, and there is a partition at the center of the hall, and there is a person A here and there is another person B. Now, A can see B, but B cannot see A. Why it is so? It is very interesting that if you just think that A can see B, how A can see? Because if B, there is a top light or some light, enough light near B, then that light will go to the mirror and get reflected. So, A shall be able to see B in the mirror, behind the mirror, as you know, the virtual image. But if A is in the total darkness, then no light will go from A to B, therefore, B cannot see A. That means, actually light help us to see, but we cannot see light. This is very important, that visible light, it means that light by which we can see, but that particular light we cannot see. Let us check with some example. I have a laser torch over here. You see that I am going to shine this laser on this screen. You cannot see the path of the light. The laser is on here, the light is falling here, and we can see the spot only, but we cannot see the path of the light. That means, light is invisible, but when light falls on some object or something, light get diffused, reflected from there, and therefore, we can see the object, but not the light. Next, we shall pass on to a very interesting phenomena, because as you know that first thing what you study in your class is the rectilinear propagation of light. Rectilinear propagation of light. That means, light always travel in a straight line. If there is a source, it travels in a straight line. And in your school, in the book, very common example is that there are 3 cardboards, and those cardboards have 3 holes at the center, and if they are aligned perfectly in a straight line, then if there is a candle here, then with your eye you can see. This is a very common experiment which has been given in your book, but a student of class 6, they said, sir, why not the light can go like this and then come from this, then go for this, and then I can see, because light we have heard that it is a wave type. So, it can go like a wave, this side or that side, this way can go. So, this is not a exact proof that light travels in a straight line. Present time, they have used another device. They take a straw, bent straw. If there is a flame over here, like say this is any source of light, this star. If you look from here, you can see this. But if the bent straw is bent, then you won't be able to, even if you shift it here, you won't be able to see. This is a definite proof. but we are going to show you that how light really travel in a straight line. For that, we are arranging something that we take two mirrors. Just I set this like that. There are two mirrors. This is one mirror almost perpendicular to another mirror, and a laser light is shown from here. The light falls over here, then get reflected here, and then it again reflected from the second mirror. But as you can see that you cannot see these rays of light. Now, what I do, if you come over here, I have some chalk dust, and you can take the chalk dust in your hand. Now, I have make the arrangement complete. Now, you start clapping like this. When you clap, the chalk dust goes in the air, and those dust particle when falls on this, each particle is scattering the light which is falling on them. So, now we have another point, another word which is called scattering. Previously, we have seen that we talked about the rectilinear propagation of light. In this experiment, we shall see by ourselves that this light is really travelling in a straight line, wonderful. But this scattering, what is scattering? Scattering is something that when light falls on small particles, they absorb the light and then they re-emit in all directions. And very interestingly, all the physical phenomena you will see in gravitation, that the rule of gravitation, that force is proportional to 1 by r square. In case of magnetism, it is again r square. In case of electrostatics, again 1 by r square. Even when light passes from it, the intensity of light falls down with 1 upon r square. But what is the difference? Ordinary light and the laser light. Actually, you should know the laser light does not lose its intensity by 1 by r square. It gets absorbed in particles, but it goes on long distance. That is why laser has a very intense and is a very long range. Now, when laser falls on a particle, that particle absorbs energy, and this energy is scattered in all directions. And this scattering also depends on some factor, though in your book it is not given. There is a scattering factor alpha, which depends on the thickness of or the particle size, its volume, wavelength of light, and there is a 2 factor over here. This is called scattering factor. So, this scattering factor alpha is given by this. So, you can see if the particle is larger, then lambda has to be larger. But I know that as a preliminary lecture, if I talk about lambda, particle size, scattering, you won't be able to understand. Let us get down to a lower concept. What is that? In this experiment, you see that mirror always has 2 layers, and the mirroring is actually behind this. So, when laser light falls here, light normally gets reflected from the upper surface, and a portion of this goes down to the lower surface, and actual reflection takes place in the lower surface. So, from the lower surface, reflected light goes and it transmitted parallelly to the first ray. So, this is the second one, this is first ray, this is second ray. Again from here there is another ray goes down from the upper surface, and again it goes to this level and it starts going in this direction. But obviously, the second one, which is getting reflected from a mirror surface, is maximum intense. So, when you look at this beam, the beam which is being reflected, you can see that the second or central one is the strongest one, and this part, this is weak. And another very interesting feature, we can see that when the chalk particles is falling on the mirror, they are also scattering the light, and therefore, some light, if it is a parallel surface, obviously all mirrors I mean the surfaces are parallel. So, what happened, this surface, the mirror surface, and this surface acts like a mirror. So, they are like parallel mirrors. So, what happened, they produces the reflection on the other side. So, a system of spots you can see in this experiment, that large number of spots can be seen, which is because of the successive reflection, and also it is because of the two parallel light. And as if it is an infinite system as produced. So, you see from a single experiment of this, what are the things we learned? We learned that the particle scatters, and that is why we can see the beam. Second part is that this scattering is able to see the the ray of light which is travelling in a straight line, and also if you put a protector on your mirror, then from the protector you can get the value of the angle of incidence and angle of reflection, from where you can get verify the law of reflection, that is angle of incidence is equal to angle of reflection. And here, and the last beautiful thing is that first ray is reflected from the upper surface, second ray goes to the real mirrored surface. So, this is the intense part, and third one again the third one. So, three rays are really reflected from the first mirror as well from second mirror, but from the second mirror it is very prominent that three rays are going out. So, this is in a single experiment we have learned how light behaves are reflected in a two parallel mirrors or two mirrors at an angle, and also what is scattering, and the second part of the beam is maximum intense. So, these things all are written in the book. Now, our experiment has make you able to understand why these things are happening, because you can see them by yourself. Thank you very much.